Hey everybody, Mr. Justin here with the Hernando County Public Library System, and welcome back to our weekly science experiment. I hope everybody is ready to have a fun one today. You can either watch what we do here today and learn what we're going to talk about, or you can also, if you have the supplies at home, you can go ahead and do it along with me or do it after you watch the video. But it's going to be a very fun one today. It's going to kind of build off what we talked about last week with chemical reactions, but there's going to be something at play here today too. What we're actually going to make is a homemade lava lamp. You may have seen lava lamps in stores or people's houses where you've got it's a lamp, it lights up, and there's like these little colorful bubbles kind of going around slowly or quickly depending on the lamp. It's really kind of groovy and cool to watch. Well, we're going to make one today using a couple different scientific principles, scientific facts, things. And what we're going to need today is a bottle. You can do any sort of water bottle. I've got this little shape bottle here too. Any kind of bottle is going to work. I have vegetable oil. You can also do baby oil. Baby oil is going to give you more clear liquid, but the effect isn't going to be as strong as with vegetable oil, but baby oil is a possibility. I also have food coloring, water, a funnel just to make things a little easier, and we have little Alka-Seltzer tablets, and that's going to help demonstrate what we're going to show today. So what we're going to do today is take our bottle, and I'm going to start with the vegetable oil. So I'm going to open up the vegetable oil, and I'm going to use the funnel and pour about 2/3 to 3/4 of the way filled. So most of the Let's take that off, make things a little easier. And we're going to go ahead and, like I said, that's going to be good. Actually, that might be a little too much, so I'm going to pour some back in. There we go. That should be good right there. And we're going to fill the rest of it with water. So I'm going to take the funnel again. And let's watch what's going to happen when we mix the water with the oil. Like I said, I'm going to fill it up most of the way again with the water. We see some bubbles forming. We see some bubbles. It's kind of bubbling and bubbling, but what we actually saw is even though we put the water in second, the water is actually going to the bottom of the bottle, and the oil is still on top. And are they mixing at all? No, they're staying completely separate from each other. So how does that work? Why is water and oil not mixing? Well, that's because the water is more dense than the oil. So today we are going to be talking a little bit about density. And so density is how much mass there is of something in a given space. And mass is like how much matter is in something, or how many molecules of matter. And so we can see that the mass of the water is a little bigger than the mass of is a little more than the mass of the vegetable oil. So that's why we see the water down there. The vegetable oil is up on top, and they're not mixing at all. So that's going to help kind of start off our investigation today. So next thing I'm going to do is take some food coloring, and I chose red today. I'm going to put a few drops here. As you can see, this is cool too. The food coloring, the dye does not like the vegetable oil. It's a different density. It's similar to the water, right? So it's kind of like little dots kind of traveling down into the water. And right now it's actually just staying on top of the water. But what's going to happen in a second is it's going to the bubbles are going to burst, and it's going to make the bottom half of the bottle, the water part, going to cover all in the red food coloring color, and that'll happen in just a second. Let me just I don't want to shake the whole thing, but let's see if we can get them to pop a little bit. While we're waiting for that to happen, you're going to go ahead and get your Alka-Seltzer, your tablets, your antacid. And we got the little tablet right here, and I'm just going to break it in half. You can even break it in fourths if you want, but I'm just going to break it in half for now. And as we can see, this still has not, though, it's almost there. It's almost going. Let's see if it's going to pop for us. There we go. We finally have the red going all over the water, so that's fine. We're going to mix it up a little bit even more in just a minute as we add our antacid. And it might be a good idea to have napkins or paper towels or a tablecloth around as you do this. All right, there we go. So we now have the red with the food coloring mixing up, and that's the water right there. And on top is the vegetable oil. Remember, they've got different density, which is why they are separated and not mixing with each other. So what's going to happen is when we add the antacid, that's going to create, remember from last week, a chemical reaction. And so it's going to create, when this meets up with like the vegetable oil and the water, it's going to fizz up and create that carbon dioxide that we did last week when we had the balloon fill up or the plastic bag filled up and created the air, created the carbon dioxide. We're going to see that again with this, but let's see which way how it's going to look when we do this today. So I'm going to put this in here, and then you can leave the lid on. I like to kind of put the lid on just to watch it all. So I'm going to put this in here, and you're going to see that it is going straight down to the water because it's a little heavier, and you can see that it is now creating bubbles. It's fizzing up, and it's creating little bubbles of carbon dioxide going up, which is going to be the food coloring in the water going up and filling up into the vegetable oil. But because the density is different, it's going back down. So we're creating a cool little lava lamp effect using the Alka-Seltzer and using the water and the vegetable oil, the fact that they don't want to mix. And there we go. But you know what? Let's go ahead and do it a little more, because again, once the antacid is done, once it all fizzes up, it'll stop doing its reaction. So I'll just put another one in there, and it'll keep going and doing its own thing. So again, the water and the oil do not mix because they've got different densities, and the water is going to be more dense, so it's going to be underneath. And when we add the antacid, it's going to create a chemical reaction of carbon dioxide. The bubbles are going to go up into the vegetable oil and then come back down, creating a cool little effect that kind of looks like a little lava lamp. So there we go. I hope everybody enjoyed our experiment today as we talked about chemical reactions again, but especially with density between water and vegetable oil. So thank you so much for joining us. I hope everybody had fun, and I hope everybody's able to do the experiment on their own, and we'll see you all next week. If you want to see our videos every week, you can go to our website, you can go to our Facebook page, or you can also smash that subscribe button that's right there underneath us, and you'll get our weekly science experiment videos recommended to you every week on YouTube. So thank you so much for joining us. Have a good one. Bye.